Row 1. Text, Notepad window, text editor, editing. Remember, this is not teaching man teacher. It is useful for recalling, when exam coming man student. Just close eyes and listen. Based selected. On. Based. Cap G. Subject, Microcontroller, 17534. These are mostly important questions which is always repeat. Form top to end it reduce repeated changes. X question 1 is more important than 2 in notes. And note warning sign that this is not all chapter.
Microcontroller Chapter 1. 1. What is a bus? Describe the different types of buses used in 8051 microcontroller. ANS, 1 mark definition of bus, 3 mark -1x3, 3 bus types explanation. A bus is a set of physical connection used for communication between CPU and peripherals. There are 3 types of buses: address bus, data bus, and control bus. 1. Address bus. The address bus is unidirectional, over which the microcontroller sends an address code to the memory, or input/output. The size of the address bus is specified by the number of bits it can handle. The more bits there are in the address bus, the more memory locations a microcontroller can access. A 16-bit address bus is capable of addressing 64K addresses. 2. Bus. The data bus is bi-directional, on which data or instruction codes are transferred into the microcontroller, or on which the result of an operation or computation is sent out from the microcontroller to the memory, or input/output. Depending on the particular microcontroller, the data bus can handle 8-bit or 16-bit data. 3. Control bus. The control bus is used by the microcontroller to send out or receive timing and control signals like read and write in order to coordinate and regulate its operation, and to communicate with other devices, i.e. memory, or input/output. 2. State the difference between Harvard and Von Neumann architectures with suitable diagram. ANS. Harvard architecture diagram 1 mark, Von Neumann's architecture diagram 1 mark. Any 2 difference points 2 marks. Microcontroller Chapter 1. 2. Draw the block diagram of 8051 microcontroller. ANS 4 marks for correct diagram. Microcontroller Chapter 1. 3. F. Distinguish between microprocessor and microcontroller. Any 4 points. ANS 1x 4 marks for each point. Describe any 4 selection factors of microcontroller. ANS 1 mark for each criterion. Any 4 should be considered. The selection of microcontroller depends upon the type of application. The following factors must be considered while selecting the microcontroller. 1. Word length. The word length of microcontroller is either 8, 16, or 32-bit. As the word length increases, the cost, power dissipation, and speed of the Microcontroller Chapter 1. 4. Microcontroller increases. 2. Power dissipation. It depends upon various factors like clock frequency, speed, supply voltage, VLSI technology, etc. For battery-operated embedded systems, we must use low-power microcontrollers. 3. Clock frequency. The speed of an embedded system depends upon the clock frequency. The clock frequency depends upon the application. 4. Instruction set. On the basis of instructions, microcontrollers are classified into 2 categories. 1. CISC. 2. RISC. CISC system improves software flexibility. Hence it is used in general-purpose systems. Risk improves speed of the system for the particular applications. 5. Internal resources. The internal resources are ROM, RAM, EEPROM, Flash ROM, UART, Timer, Watchdog Timer, PWM, ADC, DAC, Network Interface, Wireless Interface, etc. It depends upon the application for which microcontroller is going to be used. 6. I/O capabilities. The number of I/O ports, size and characteristics of each I/O port, speed of operation of the I/O port, serial port, or parallel ports. These are the considerations needed to ascertain. Describe the function of address, data, and control bus. 1.5 M1 ST and 2 ND point and 1 M3 RD point, ANS. 1. Address bus. The address bus is unidirectional over which the microcontroller sends an address code to the memory, or input/output. The size of the address bus is specified by the number of bits it can handle. The more bits there are in the address bus, the more memory locations a microcontroller can access. A 16-bit address bus is capable of addressing 64K addresses. 2. Data bus. The data bus is bi-directional on which data, or instruction codes are transferred into the microcontroller, or on which the result of an operation or computation is sent out from the microcontroller to the memory, or input/output. Depending on the particular microcontroller, the data bus can handle 8-bit or 16-bit data. 3. Control bus. The control bus is used by the microcontroller to send out, or receive timing, and control signals like read and write in order to coordinate and regulate its operation, and to communicate with other devices, i.e. memory, or input/output. F. Draw the general block diagram of microprocessor. Explain the function of each block. ANS, 2M diagram, 2M explanation. Marks should be given for any other correct diagram and explanation. Microcontroller Chapter 1. 5. A typical microprocessor architecture is shown in figure above. The various functional units are as follows. 1. Buses. A bus has a wire or line for each bit, and thus allows exchange of all bits of a word in parallel. The processing of bits in the P is also in parallel. The buses can thus be viewed as data highways. The width of a bus is the number of signal lines that constitute the bus. The figure shows for simplicity 3 buses for distinct functions. Over the address bus, the P transmits the address of that I/O device or memory locations which it desires to access. This address is received by all the devices connected to the processor, but only the device which has been addressed responds. The data bus is used by the P to send and receive data to and from different devices, I/O and memory, including instructions stored in memory. Obviously, the address bus is unidirectional, and the data bus is bidirectional. The control bus is used for transmitting and receiving control signals between the P and various devices in the system. 2. ALU, Arithmetic Logic Unit, ALU. The arithmetic logic unit is a combinational network that performs arithmetic and logical operations on the data. 3. Internal registers. A number of registers are normally included in the microprocessor. These are used for temporary storage of data, instructions, and addresses during execution of a program. Those in the Intel 8085 microprocessor are typical as accumulator 2, general-purpose registers, or scratch pad memory. There are 6 general-purpose 8-bit registers that can be used by the programmer for a variety of purposes. These registers, labeled as B, C, D, E, H, and L, can be used individually, example, when operation on 8-bit data is desired, or in pairs, example, when a 16-bit address is to be stored. Only B, C, D, and HL pairs are allowed. 3. Instruction register, IR, 4, program counter, etc. 3. Memory unit. Memories like RAM and ROM are not inbuilt in any microprocessor. Memory is interfaced externally to increase the storage capacity of microprocessor. The maximum memory capacity, which can be interfaced, is decided by the number of address lines available for control unit. It generates the different control signals required for communication. 5. Input/output devices. Microprocessors doesn't have ports, so external peripherals ICs like 8155 and 8255 PPI are used to communicate with I/O devices. Microcontroller Chapter 1. 6. F. Sketch block diagram of microcomputer. Label each block and states function of each block. ANS, 2M diagram, 2M function. Any relevant and correct explanation should be given marks. A microcomputer has three basic blocks: a central processing unit, CPU, a memory unit, and an input/output unit. The CPU executes all the instructions and performs arithmetic and logic operations on data. The CPU of the microcomputer is called the microprocessor. The microprocessor is typically a single VLSI, very large-scale integration, chip that contains all the registers, control unit, and arithmetic/logic circuits of the microcomputer. A memory unit stores both data and instructions. The memory section typically contains ROM and RAM chips. The ROM can only be read and is non-volatile, that is, it retains its contents when the power is turned off. A ROM is typically used to store instructions and data that do not change. For example, it might store a table of codes for outputting data to a display external to the microcomputer for turning on a digit from 0 to 9.1 can read from and write into a RAM. The RAM is volatile, that is, it does not retain its contents when the power is turned off. A RAM is used to store programs and data that are temporary and might change during the course of executing a program. An I/0, input/output, unit transfers data between the microcomputer and the external devices via I/0 ports, registers. The transfer involves data, status, and control signals. The Microcomputer System Bus contains 3 buses, which carry all the address, data, and control information involved in program execution. These. Microcontroller Chapter 1. 7. Buses connect the microprocessor, CPU, to each of the ROM, RAM, and I/O chips so that information transfer between the microprocessor and any of the other elements can take place. C. Describe the function of following instructions of 8051 microcontroller. 1. MOVX A, DPTR2. Swap A3. Mul AB4. Move A, R0 ANS1 mark for each instruction 1. MOVX A, DPTR description. This instruction moves the contents of the external RAM memory pointed by, or stored in, DPTR to accumulator. No of bytes. 1 byte addressing mode. Register example. Move DPTR, hashtag 2000H, DPTR equals 2000H, external RAM address, move A, at DPTR, 2000H equals 0BH, A equals 0BH. 2. Swap A description. This instruction exchanges bits 0 to 3 of the accumulator with bits 4 to 7 of the accumulator. This instruction is identical to executing RRA or RLA 4 times. No of bytes. 1 byte addressing mode. Register specific example. Move A, hashtag 59H, A equals 59H swap A equals 95H3. Mul AB description. Multiples the unsigned value of the accumulator by the unsigned value of the B register. The least significant byte of the result is placed in the accumulator, and the most significant byte is placed in the B register. The carry flag, C, is always cleared. The overflow flag, OV, is set if the result is greater than 255, if the most significant byte is not 0, otherwise it is cleared. No of bytes. 1 byte addressing mode. Register or register specific example. Move A, number 5 move B, number 7 mul AB, A equals 35 equals 23H, B equals 004. MOVA are 0. Microcontroller Chapter 1. 8. Description. This instruction moves the contents of the register R0 to accumulator. No of bytes. 1 byte addressing mode. Register example. Move R0, hashtag 35H. R0 equals 35H move A, R0, A equals 35H. F. Distinguish between microprocessor and microcontroller. Any 4 points, ANS, 1x 4 marks for each point. Microcontroller Chapter 1. 9.